Hi everyone, welcome back. I hope you all had a great weekend, well rested, and ready to get back to work. So we're going to jump right into it. Today's lesson is going to be on graphing distance versus time graphs. So if you remember from last week, we talked about balanced and unbalanced forces. So when you think about an unbalanced force, remember we had that example of the two football players kind of running in opposite directions and then boom, hitting each other. We notice that they not only change their speed, but they change their direction. So today we're going to look at how we can kind of visualize that in the form of a graph. How can we track the movement of an object in this useful way of kind of picturing our data. This is going to be really helpful not only in science, but also in math classes. So this is a useful skill to have. All right, so what's our date today? March 30th, 2020. Our topic, distance versus time graphs. The standard, we are working with the 6th grade standard. Measure and graph. So measure and graph, those are our two action verbs we're trying to do. Distance versus time for an object moving at a constant speed. Interpret this relationship. So what does it mean to interpret? This means to kind of draw conclusions from the data, right? Or make some type of link between what's being shown and what you can conclude. Our goal for today, I will be able to read and create graphs showing distance versus time. Our vocabulary, we have origin, positive acceleration, negative acceleration, distance, time, velocity, and speed. And what are we working towards answering? How can you compare the speeds of objects based on a distance versus time graph? And you're going to end today with a 3-question exit ticket under the Assignments tab. All right, so here's a good image of a distance versus time graph. And I want to just take a minute to get y'all familiar with the different parts of it. So first we have our origin. That is the starting location in our distance versus time graph. Next, on our x-axis, what are we measuring? Yep, time in the unit of seconds. That is our dependent variable. And on the y-axis, what are we measuring? This is our y-axis. We are measuring distance with the unit of meters. This is our independent variable. Remember, this is the one that is changing. So if you notice, we start here at the beginning of our graph. Now we're going to be moving away from the origin. So our distance is increasing. We started at a distance of 0 meters. Now from our original point, we are 10 meters away. Then for the next about 5 or 6 seconds, what's happening in this area? Right, that's right. No motion, right? It's not moving, it's staying put. Then you notice that we're actually returning back to our origin. So we're going back to where we started. And that's why we curve back down. Another really useful part about this graph is it can actually show us some good information about the acceleration. So y'all might have heard this in terms of being in a car and all of a sudden it accelerates, it speeds up really fast. But it's not only about how it speeds up, it's also about how it slows down. So we have two different types of acceleration. We have the positive acceleration, which is an increase in speed, it's speeding up. And we have our negative acceleration, and that is a decrease in speed or slowing down. So if you look at our graph down here, we could see maybe this is an example of how a car is driving. The car is driving pretty steady, for the first 4 hours of its journey. And then it takes a break, rest stop for 2 hours. And then it's continuing on its speed, going 50 kilometers per hour. And then maybe it's hitting some traffic. So now it's slowing down to 25 kilometers per hour. So we had a positive acceleration from 6 hours to about 9 hours. And then after that, you see that it's now, this line is not as steep. When it's not as steep, we're going to see a negative acceleration. So it's actually slowing down from that point on. All right, so when y'all see these graphs, a lot of times they're just telling stories. So we could say, for example, Miss Hussein is at her house. She's driving to work, driving to work, driving to work. All of a sudden, she hits standstill traffic. She's not moving for like almost 2 hours. Look at that. She gets to work really late, but now she's speeding up, speeding up, speeding up. She stays at work for about 2 hours. And then at the end of her long, long day, she drives all the way back. See how it told a story? So when y'all see these, try to come up with a story yourself. It helps to make sense of it. So let's look at these questions, and you're going to be answering these on your worksheet. What is happening between points B and C? Remember my story, what happened that I was kind of just staying still? I was stuck in traffic, right? So did my distance change? No. I was at 3 kilometers. Oops. At point B, and then I stayed at 3 kilometers at point C. So what happened? There was no movement. Okay. What about number 2? Is the person moving faster during line segment AB or line segment CD? So if you think back to our last slide about acceleration, when did we say that the graph is going to be showing us faster speed? Yep, that's right, when the line is steeper. So you notice that is steeper from C to D. It has a higher slope. And lastly, number 3, what is a person doing between E and F? What did we say? Miss Hussein left work and is going back home, right? So she's traveled all the way 12 kilometers and has come back to her house, 0 kilometers, right? So she is returning to the origin. Okay, so you're also going to be answering this question in your handout. How would you describe the change in speed in the following graph? So we want to notice what's happening to the speed. So we look at time versus our distance. As time is passing, our distance is increasing in segment A. Then you notice, are we increasing our distance more quickly or more slowly in segment B? If you said more quickly, you are right. This is a positive acceleration. Right? It is speeding up at that point. So overall, when we want to describe our change in speed, we can say that it is speeding up. So that is it for our mini lesson. So you can check off that you have completed distance versus time lesson over here. Now you're going to be moving on to the CPOMS tutorial. And you are going to be practicing interpreting distance versus time graphs. So go ahead and click on the link right over here. It's going to take you straight to the tutorial. At the very end of this tutorial, there's going to be a certificate. I would like you to take a screenshot of that, and you can either upload it to class chat room or email it to me. Okay, that is up to you. But that's showing me that you went through, completed that tutorial, and did the practice. From there, you're going to move on to the Moving Man Simulator and click on this next link to watch that video and answer the analysis questions starting on page 3.